right, we're going to go ahead and start with two new ways to complete a quantitative graph, okay, of quantitative data. And so we've just finished off on our box plots, our box and whisker plots, and learned about all the outliers and everything. So let's take a look at the ones we're going to do today. We're going to make a dot plot. So where each piece of data is represented by a dot, okay? I know that sounds a little obvious. But then also, one thing that's important to note is that you actually do have the ability to know what each piece of data is, how many twos there are, and how many threes there are, and so on and so forth. Okay, so that's one thing we want to keep straight and watch with what we're doing today. With a box plot, we couldn't tell what all the individual pieces of data were. But with these ones today, we will be able to tell what the individual pieces of data are. So that's important. All right. So after we do dot plot, then we're going to do this thing called a stem plot, a stem and leaf plot. And we're going to talk about a split stem, what that is when we split the stem. And then third thing is we're going to do this back-to-back stem plot because that's going to be then comparing two sets of data. So that's what we primarily use the back-to-back stem plots for. All right. So let's talk about here's how we do this. Dot plots first. So it is one of the quickest and simplest graphs to construct. You don't want to do it when there's too much pieces of data. And again, each piece of data is its own dot. So make sure that you draw a horizontal axis, which because this is quantitative data, it is a number line. So it'll go in order from least to greatest, okay? And the scale, you have to have that, which will go incorporate all the values from the min to the max. And then you just put a dot above each value. Now, one thing to keep in mind is that make sure when you do that, that you're giving each dot the same amount of space when you stack up. So let's see. So whenever we do that here, so you can see these little circles here are the same amount of height, so that, for example, when you look at this, you know, here this is 2, and then right next to it, the same level is the second one here. See, and if I'm here, then this is the fifth high, and this is the fifth high, and this is the fifth high, and this is the fifth high. Okay, so they're given the same space in their heights so that the area principle is not violated. Because then, if something looks taller, it's because it has more frequencies in it, has higher frequency, and it is taller because there's more data in there. And if something looks twice as large, like this bar here looks twice as large as this bar here, it is because they have twice as many pieces of data in it than the other. Okay, so that's one thing that we want to watch. So let's go on down here to this one that you're going to practice. Okay, and so this is a survey of students and people and how long does it take you to eat breakfast. So here are the results that we got. So these are minutes and so here are the minutes, and then here are people. And so this is saying 6 people take 0 minutes to eat breakfast. I don't know if they're grabbing it on the go or if they're just not eating breakfast, okay? 2 people are taking 1 minute to eat breakfast, and so on and so forth, okay? So let's make a dot plot. So we know that we want to start with our x-axis, or yes, our axis down here, okay? And so there's that. And then we need to make a scale. We want things that are spread out evenly. So let's see if I can do that here. So we're going to put our values here. And, we also do want to make sure that we label our axes. Okay, so put this on there. So let's see here. Okay, and so on. I want to make sure that I incorporate all the values. All right, so there's all my marks evenly spaced. And so then I'm going to come back here below it and I'm going to put my, label the values. Okay, so here I have got the one. Actually, I think I needed to start at 0. Okay, so I wanted to start at 0 and then 1 and so on. Okay, so label those there. And now let's also make sure that you label what the x-axis is. And so what are each one of these dots going to be representing? Okay, well, each dot, I believe, is going to be representing the number of minutes that it takes to eat breakfast. Okay, so then we want to make sure that we are stating that. So here we would label, context is everything in this class. That's important. This is math context application. So this is the number of minutes eat breakfast. Okay, so make sure you label that. And so these are our minutes. Now, let's take a look. How do you want to represent this? Well, I see that I had 6 that had 0. So I want to make sure that I've got these things equally spaced apart. And so I kind of have the luxury because of the way that my little computer thing here, my computer program works. I can make these all, the same amount of space like this. So that's 1, 2, 3, 4, 4, 5, and 6. So there is that. So see, now I have those evenly spaced. Okay, and the next one, what is that next one? 1 minute has 2 people. Okay, so again, I have the luxury of being able to do this digitally, and then I can just move this. So see how they are lining up next to each other, so that these two are the same height as those two, and so on. And so then I'm just going to give you a few moments to finish going in there and doing your points, making sure that you are keeping all of these things lined up horizontally. Okay, so as you do that, line it up horizontally. All right, when you are done, then you've got something that looks like this. There we go. Minutes to eat breakfast, and there are your things. Now, this is interesting. We kind of have like 2 sets of data, the people that eat fast and the people that eat slower. And so we'll talk about that later after in our next unit. Okay, that is dot plots. Done with those. Next, stem and leaf plots. So let's talk about what the qualities for a stem and leaf plot is. So here you can see some stem and leaf plots. Okay, here are 20 females and their AP statistics students and how many pairs of shoes they have. So we want to construct a stem plot. So this is one set of data, not 2 sets of data because there's 2 rows. Now, so what we're going to want to do, of course, is see what's the minimum and the maximum. So what is the span of our numbers? So I'm going to look through here, and to me it looks like 13 is the lowest, and to me it looks like 57 is the highest. Okay, so I want to incorporate values, that are in the 10s, the 20s, the 30s, the 40s, the 50s. Okay, you're going to want to have 5 to 10 stems here. 5 to 10 stems. And that's going to lead into something that we're going to do the next day, tomorrow, with histograms, and we'll have 5 to 10 bins of data. So we have 5 to 10 stems. All right. So what I do is I go ahead and put my 1, 2, 3, 4, 5, and these are the stems. These are the tens place. And then over here, now we're going to add leaves. And each leaf comes from one of these pieces of data. So for example, I'm going to put a dot. Here's 13. Here's ones that go in the ones stem. 13, 19, and 13, and then 15. Okay? So those are the ones 13, 13, 19, 13, and 15. Here's those. And after, this is kind of like a rough sketch, a rough draft. Ultimately, though, look at what's happening right here. Okay, so let me see if I can't zoom in on that. So ultimately, what's happening is we want the values in our stem to be in order from least to greatest. So that is a difficult thing when you have a lot of data. So we can't do too much data for a stem plot. Okay, so see here, this was kind of like our rough draft, and then we went and changed it so that they are in order. Okay, and so we do that for each one of these sections. So then I found all the ones that were in the 20s, and I ordered them, and then the 30s, and I ordered them. So notice what this means. This means that, for example, that right there is the number 13. The 1 is the tens place, and the 3 is the ones place. Okay, and for example, this number is 30. Okay, so one of the benefits of a stem and leaf plot is that this also, like a dot plot, maintains all the individual pieces of data. I can still see what the individual pieces of data in my data set are. Now, the final thing you must do is add a key so we know what this is representing. So here's the example. 4 with the line here, and then the 9 represents a female student reported having 49 pairs of shoes. Okay, so there's what's happening with that. And the reason the key is so important is because you will see here on this one that we're about to practice that it will not be the tens place and the ones place like the problem we just did. Here is Sam, and he got his friends together to do the long jump, and here are these results in meters. So I notice these all are in decimal places, okay? I also am going to look and see what my least to greatest are so I can decide how I want to do my stem. So I'm going to come in here, and here's my stem. All right. And so let's see. The lowest is, I guess these are in order from least to greatest, so that's easy. 2.3, and the highest is 5. Okay. So I'm going to just go ahead and do a stem for the 2s, the 3s, the 4s, and the 5s. Okay. Even though that's not quite 5 bins, 4 is good enough, I guess. So I'm going to do stems with those bins. And again, these are the long jump values in meters. Okay, so there's my stems. All right, so now I just need to order them and put the ones. So the ones that go here on the 2s are, it's nice that these are in order. 0.3, 0.5, 0.5. So we've got 0.3 space 0.5 space 5, 7, and then 8. Okay? Now, watch what's going to happen here. On this one, and again, this is nice because they're in order, but 2, 6, and 6. Okay? If there are repeats, then you do still have the repeats here. But also, similarly, like the dot plot, how we had to make sure everything lined up, same thing here. Do you see this here, how we're making sure that those stack on top of each other, and so each piece of data is getting the same amount of space. So if something looks twice as much, it is twice as much. Okay? Now in the 4s, there's just one of those, and then in the 5s, there's just one of those. Now what? Now the key. And you'll see why this is so important. So when we say, okay, this is the key, and I've got this. Would you just pick one of these ones over here on the left? So I'm going to say 2, and the line, and then 3. And so what does that represent? That equals a 2.3 meters on the long jump. So the context is important. Okay, remember this class is all about the context, math context. Okay, so that is how you do that. All right. Okay, let's see what we got here. So we got another one. Okay, that's the end of that kind. Now we're going to visit the next kind of stem plot, splitting the stems. So let's take a look at what that's doing. So splitting the stems, not back to back. We're going to not do back to back. We're going to do splitting the stems. So let's talk about that. All right, take a look. This is a nice little picture. It's kind of blurry, but it shows you what splitting the stems does for you. So, depending on how much data you have, for example, with this stem and leaf plot here, there's quite a bit of data in each one of these stems, in particular in this 2. So if this was, I guess these are in the 20s, okay? Because I can see down here 1 and then a 2. Oh, and another thing, I see this person had commas. You can have commas. You don't have to, okay? It's just as long as you're evenly spacing them. So commas are allowed. All right, but anyway, look at there's kind of a lot in that 2. So maybe you think to yourself, that's kind of a lot to handle in one stem. You know, that's a lot of numbers. Now I'm going to have to keep it in order and figure out the order from. So sometimes people will decide, if there's a lot of data, more data to deal with, to split the stems. So look at what happened. So you can see over here on the left, here are the 0, 1s. So these are the values that are in the zeros place, so they have no 10s. So that's just the 1, 1, 3, 6, 7, 7, and 8. Well, look at how those became over here. 1, 1, 3 in the first half of the stem, and 6, 7, 7, 8. So this zeros got split, just like the 10s, 10, 12, 12, 13, and 18, also got split. So the 10, 12, 12, 13, and then 18. All right, so let's talk about what is in each stem. Okay, it must be the same amount of digits. You cannot have, say, like 5 digits in one and 3 digits in the other. Same number of possible digit values. That's kind of hard to explain. For example, here's what I mean. So everything in this row here, all the leaves in this first part of the stem are going to be digits 0 up to 4. Digits 0, 1, 2, 3, and 4. Okay? So if you had a, 0, 1s, 2s, 3s, or 4s, they go there because that's 5 digits. 0, 1, 2, 3, and 4. 5 digits. So that puts the other 5 digits here. So the digits in the second stem are going to be the 5, 6, 7, 8, and the 9s. So 5, 6, 7, 8, 9. So 5 digits there as well. All right, so that's standard. If you split the stem, it needs to be split that way. So 0 through 4 are in this one, the top one, and 5 through 9s are in the next one. Okay, and that happens on every stem. So the 1s, so the 10s up to 14s, and then this one would be 15s up to 19s. Okay, the next one would be the 20s up to the 24s, and then the 25s up to the 29s, and so on. All right, so that's how you do that. So what I have then is for us to practice one of those. So let's take a look here. I think that I need to shrink this back down. I zoomed in, kind of messed it up there. Okay, so let's see if I can scoot on down. All right, so here we have this information here. We're going to split these stems. When you have too much data in a small range, you will most likely choose to split the stem. Create a split stem and leaf plot for the number of touchdown passes thrown during the playoffs. Here's the table 1. Here's the information for the touchdown passes. Okay, so let's go ahead then. And then I'll keep this in mind so that we can use that later. All right, so here we go. Let's start it off. Okay, so let's take a look. What are our values going from? It looks like, this is easy. They're listed from greatest to least. So the least is 6, and then the greatest is that 37. So we'll go on over here then, and we'll start us a split stem. So here we go. All right, and so now I'm going to come over here with my numbers, and we're going to go from least to greatest. Okay, so 0, 0. I'm splitting my stem. So then 0, 0, and then get back in there. 1, 1, 2, 2, 3, 3. Okay, so there's my split stem. Now we're going to put in the leaves. So luckily, this is nice in that it's already in order from least to greatest. So that's nice. Okay, so keep in mind, right over here, look at what I have. The first stem would be the digits 0 to 4, and the second one would be the digits 5 to 9. So where is this 6 going to go? It's going to go here in this second one, not the first one. All right, so then I put that 6 in there. I'm actually just going to go ahead and do it from least to greatest. So I put that 6 in there. And you could put a comma if you wanted to. You don't have to. And then the 9. All right, so let's do the ones. 12, 12, 14, 14, 14. Those are the ones that are going to go in this first stem. 12, 12, 14. Ooh, I need to put a space in between there. 12, 12, 14, 14, 14. Okay, and then remember the digits 5 to 9 go in the next one. So that's the 15, 16, 18, 18, 18, 18, and 19, 19. So quite a bit in that one. So 15, 16, 18. There's four 18s. And you list them all out. 2 of the 19s. Right? And now I got my 20. So let's see which ones go in the first stem. 20, 20, 21, 21, 21, 22, 22, 22, 23. Those go in that first stem. Okay, so that was 20. And so on. Okay, so you get all of those in there. So you keep putting those in there. And then once we get done putting them in there, okay, and the next one has 28, 28, 29. The next one has 32 and 33 and 33 and then 37. Okay, so see how I did all the spacing the same so that they line up? Don't forget your key. So here comes the key. And so I'm just going to pick one of them. So let's see here. Let's do 2 and then your line and then the 8. And that equals 28 touchdown passes in the playoffs. All right, so there you go. That is how to turn a split stem or a stem and leaf plot into split stem. So let's review. Why would we choose to do this? we would choose to split that stem if we really have too much data to go in one stem. See these, there's a lot in the twos. Ooh, there's also all the ones, there's a lot in the ones. So if we didn't split these stems, man, those would be way long, difficult to number, difficult to order them from least to greatest if it's not already in order. Okay, so if it becomes cumbersome with too many numbers in one stem, splitting the stem is probably your way to go. All right, last one is this thing called back-to-back stem and leaf plots. So here we go, back to back. Let's take a look at what that's doing. All right, so I'm going to move all these guys here. Here we go, back to back. So this back to back is going to be what you're going to do when you want to compare, things. So if I have two sets of data, so for example, you can see this page here has got the set of data for females and the set of data for males. Okay, very good. So we want to then compare them. So then that's why we're going to then do a back-to-back stem and leaf plot for comparing. All right. So what I need to do is look at the data in each one of these stems. So it looks like they're going from, well, I can see the males go in the zeros to the 50s, and the females go from the teens to the 50s. All right. So then what we're going to do is then we're going to put the stem right here down in the middle. Okay, so you can see this stem is right down here in the middle. And then here we have the males on one side, whichever side you pick it to be, and then the females on this other side, whichever side you pick it to be. And you know what? I do not like this key. This is a not a good key. So we're going to fix it and make it a better key. All right. So I have labeled at the top which side are the males and which side are the females. And so let's take a look at the numbers, because this is where it gets tricky. And you take a look at this. For the males, here is 10. So that's a male that has 10 pair of shoes. But this is super duper important. This is not typical. This is not intuitive. This is not what you would naturally think. Look at this number right here for the females. That is not 31. Important. This, always reading from the stem. This is 13 for the females. Over here it was 10 for the males and 13 for the females. So you've got to be careful on that one to the left, because you read from the stem to the left. All right, very important, which is why I don't like this key right here. So I want to do a new and better key. So we're going to move this right here, and then we're going to write a new and better key. So let's do that. We're going to say, here's our key. And then what we're going to do is show something with both of these sets of data. So I'm going to say, I like to pick something where it's different for both the females and the males. For example, see, here's something I wouldn't want to pick. I wouldn't like to pick that, because that's 22 for the males and 22 for the females. That doesn't really clarify where these numbers are located and what they mean. So, I like this one down here. So I could have done that with the ones. I could have done this with the 13 for the females and 10 for the males. I'm going to use this one down here, 8, 3, and 5. So here I go. So that's going to be like this. So 8, and then the line, and then the 3 is the stem, and then the 5 is the male's leaves. All right. So that equals, so here's how I do that. I'm going to say 38 pairs of shoes for the females and 35 pairs of shoes for a male. Okay, so this is for a female, I guess, and for a male. Okay, so did you see how I defined both of those? I did a leaf on the left, the stem, and a leaf on the right, and I defined them both. Okay, now I have a sample or a practice one, I think, down here for you to do. So let's take a look at that and let you try it. Here we go. Let's see here. Yep, so here you're going to do this one down here. Here's a back-to-back stem and leaf plot that you're going to do for data A and data B. There's no context there. I wish there was. I don't have it. So go ahead and set that up and we'll see how you do. All right, so here I have done this here. So here is the key. I chose the 3 as a left leaf, the 4, and the now you might have also chosen the A's on the left and the B's on the right, and that's okay. So that's interesting. Your back-to-back stem and leaf plot could have looked different from mine, with the A's on the left and the B's on the right. But see, that's the beauty and the importance of the key, because you can set it up different ways, and we have to have it defined. So my key shows that this is 43 for data set B and 40 for data set A. All right. And if I had context, I would put that in there. All right. So you are now going to try these ones on the next page. Okay. So I think I've got all different kinds. Here's you some sim leaf plots. Would you try? Oh, this one's a dot plot. Okay. So this first number 1 is a dot plot. Number 2, oh look, I just jumped straight to the split stem and leaf. Remember split stem, 0, 0, 1, 1, 2, 2, split the stem. And then this last one, oh, look here, this is interesting. I give you some options, so you want to look and see. So first, because we have 2 different sets of data, we're going to compare the ages at the Wimbledon winners to the Masters winners. Okay. But I said you may want to also split the stem. You don't have to. We're going to see some people may have split it and some people don't. And we'll see how it comes out. All right, so that's what I want you to do for the rest of the class is try these 3, and then I'll come back with another video and we'll check and see how you did. All right, good luck.